Let's practice finding inverse trigonometric functions at specific values. What is arcsine, or sine minus 1, of negative square root of 3 over 2? If you don't really understand how to start, maybe look at this way. We want to know when is arcsine at negative square root of 3 over 2 happened, which means the question is sine of what angle gives you negative square root of 3 over 2. We see the output for the function became the input for the inverse, because those two functions are inverse for each other. The first one was inverse, the second one is original. And vice versa, the input for the inverse becomes the output for the original. That's the whole idea between inverse functions. So, maybe you even know the answer. Sine of what angle gives you negative square root of 3 over 2? Or just use the unit circle. Let's find where sine is negative square root of 3 over 2. I see that this is happening at 300 degrees, which is 5 pi over 3. And it also happens at 240 degrees, which is 4 pi over 3. So which one to use? The thing is, even though sine exists, sine and cosine both exist for all possible x from minus infinity to infinity, that's its domain, we have to restrict the domain in order to have the inverse function. What I'm talking about is this table. Inverse sine function only exists on the restricted domain. Thus, the sine function itself have to be restricted in order to have inverse function arcsine. The restriction will be from minus pi over 2 to pi over 2. Since it is the domain for the original function, it becomes the range for the inverse function. And that gives us the answer which point to choose, the 5 pi over 3 point or 4 pi over 3. Since we have to stick to the y's between negative pi over 2 and pi over 2, we only have to look at the first and fourth quadrant. As you remember, there are 4 quadrants. First and fourth quadrant. And also, we're not going to answer as 5 pi over 3. We're going to give the answer in terms of not the full circle, but only first and fourth quadrant. So, guess what will be the answer? Correct. The answer will be minus pi over 3. And maybe if you don't understand, look at this angle. It is pi over 3. So to go down to this angle, see, I go the opposite direction, which is negative pi over 3. Or you can also play by subtracting 2 pi and getting into negative pi over 3. All of this long explanation was to explain or prove to you the idea that it is indeed negative pi over 3. Now it will go a little bit faster. What is arcsine of 0? It means to answer the question 1, 2. Sine of what angle gave you 0? Well, there are so many angles, not just 0, but also pi and minus pi and 2 pi. But again, to stick to the domain of negative pi over 2 to pi over 2 for sine, we will answer 0. Does it make sense? We cannot jump to this point at all. So we have to stick to the 0 angle. 3. Arccosine of negative 1/2 means cosine of what angle gives me negative 1/2? Again, let's look at angles and see that we have several options, which is 2 pi over 3 over here, and correspondingly, where else do you see negative 1/2? Here for the cosine. But cosine also has its restricted domain, so arccosine has restricted range. The range will be from 0 to pi. That means we cannot go to this point, which is 4 pi over 3. From 0 to pi, means we are talking about first and second quadrant. First and second quadrant. The answer is 2 pi over 3. Y is 2 pi over 3 and not 4 pi over 3. Let's put it here. 2 pi over 3. And the last question is also about cosine, or basically arc cosine. If arc cosine of negative square root of 3 over 2 is what we're looking for, that means we're asking a question, cosine of what angle gave us negative square root of 3 over 2? And the answer is, let's look at the circle, which becomes messier and messier the more I work with it. We have several answers. Again, do you see them? Negative square root of 3 over 2 happens at 5 pi over 6. And it also happens at 7 pi over 6, which we're not going to be including because we're looking at the first and second quadrant. The answer is 5 pi over 6. And this is the last question, 5 pi over 6. And this is the challenge of working with inverse trigonometric functions. To get the unique answer, you need to know the restricted domains and range for them. But with time, you get used to it. Same for arctangent, work from minus pi over to 2 pi over 2, and so on.